Hi, I'm Chloe Rodriguez, Animal Welfare Specialist at Galebreaker, and today I'm going to walk you through one of my advisory visits looking at livestock housing ventilation.
Recently, Galebreaker launched an animal welfare advisory service focused on full building assessments. The aim is to understand how building design affects health, welfare and performance. Today, we're looking at how housing impacts dairy heat stress during the summer months.
This is a very typical dairy shed within the UK, and so often I'm called onto site to look at how we can optimise this environment, because it's not always that we have to rip these sheds down and start again to maximise performance.
When we arrive on farm, the first step is always speaking with the farmer. This gives us valuable insights into herd performance, cow behaviour and how the farmer feels the building is working overall. Once inside the building, especially in hot weather, the first thing we assess is cow behaviour. Are more cows standing than lying? Are they bunching together? Are there empty areas along the feed vents? These behaviours quickly tell us how well the cows are coping with the heat. Now we can look at the building's natural ventilation. We assess the side inlets, whether they're cladded, opened or curtained, and check that the inlet area is ideally 2 to 4 times larger than the outlet. The goal is to maximise the amount of fresh air entering the building and reaching the cow's microclimate. We then assess our outlet, which is our ridge. An effective ridge should allow warm, stale air to rise and exit the building. Smoke testing is the best way to check this. If the smoke rises and exits cleanly through the ridge, it's working well. If the smoke passes underneath the ridge, there isn't enough draw. For many years, cranked ridges have been used, but these are often ineffective and only provide a small fraction of the outlet area that's actually required. We then use sensors to measure temperature and humidity throughout the building, which helps pinpoint problem areas with poor airflow.
So here we have a hot wire anemometer. This measures airspeed at cow lying height. So what we're looking for is you want at least 1.5 to 2 meters a second of moving air down here at cow lying height. And then when we're then looking at heat stress conditions, when you're looking at temperature and humidity levels over 68, you're wanting at least 2 meters per second of air moving down here at cow level, ideally more, and that's how you get your convective cooling, and that's how you help keep these cows cool. So here we're looking at temperature and humidity, and when looking at our environment, it's really important that we don't just focus on temperature, but we put in the impacts of humidity, because when, for example, on a day like today, it's 18.6 degrees, so that's not too warm. However, when you combine that with a 79% humidity level, that means that combined creates a temperature and humidity, and the higher the humidity levels, the lower the ambient temperature needs to be for dairy cows to experience heat stress. This measures temperature and humidity separately, and what I've done here is I've used our THI Live website to calculate what the THI is in this building today. So today we're looking at a THI of 65. So for a day that's reasonably quite cool for a UK summer, actually the cows in here could be suffering with heat stress. So this machine now is looking at lux levels. So this is looking at lighting within the shed. Lighting's very often overlooked, particularly with UK sheds. We typically build quite dark, dingy buildings, and actually we forget how important light is, not only from a welfare point of view, but to help aid hormone production and ultimately produce healthy cows.
Once the visit is completed, I put all this information into a report with a priority action list, and ongoing support is offered to help make effective changes to the building. After the summer we experienced in 2025, we know just how big an impact of heat stress can have on UK dairy herds. It reduces lying times, increasing pressure on feet, which results in lameness, often 2 months after the heat stress event. It lowers summer conception rates, and it can dip both milk yield and quality. Poor building design and inadequate airflow can trap heat and humidity, making these issues even worse.